Namaskar, my dear friends. Let us see a simple circuit design for AMD FPGA. So what we are going to do is we are going to design a complete system design using a particular device which is called as XC7S50-1FTGB196. So what we are going to do is it is going to have 196 pin FPGA, and we will be seeing complete circuit design for this particular FPGA. Maybe you can take up you can take an example of like how to configure the FPGA or program the FPGA, and then various peripherals like power supplies and LED indicator, ADC, DAC, like user IOs. For example, you can connect push buttons, and like LED connections, deep switches, all those things. So first of all, what you can do is you can make a note of these part numbers. So these are the exact part numbers that will be compatible to each other. So you can see you have a C grade and then I grade. So C is nothing but your commercial temperature range, and I is nothing but your industrial temperature range, which is going to be -40 to 100 degrees centigrade. Okay. And about this particular FPGA we have already talked about. So let us say if you want to have a package compatibility, this particular FPGA comes into a package compatibility of XC7S50, and then it can go as well XC7S25, XC7S15, and XC7S6. Okay, and if you talk about like a 196 pin CPGA, no, this is not the one. This is the one which we are going to take. So why we have taken this particular FPGA is all of these, like XC7S6, 7S15, 7S25, and 7S50, all of them are having same compatibility. 100 IOs are there, like 100 IOs are there. Okay, high range 100 IOs are there. So this is the reason we have taken this particular FPGA. Now let us get into the circuit design directly. So what we are going to do is, this is the particular Spartan-7 FPGA schematic, and the very first thing that you can see at the top left corner is JTAG connector for programming purpose. So this is going to be used for platform cable USB 2, and you can see you have all the connections like JTAG TMS, TCK, TDO, TDI. So directly you can program using the JTAG connector, and this is connected through this particular like FPGA configuration pins. Then you can see we have the options of ADCs as well. So we have the ADC reference and ADC ground. So you can see 1.25 volt is there, which is connected to ref 1V25, and power supply for XC like ADC pin is this XADC VCC. Okay. Now you can see XADC VCC is nothing but 1.8 volt, because it is recommended from the data sheet, and that is being generated from the auxiliary voltage power supply that was generated, right? And this is after the ferrite bit we have connected to XADC VCC. Then we have configuration BVS, and then we have a program B. This is program B switch. So if you want, you can press this to reset this particular FPGA. And we have designed this particular FPGA symbol block by block, like it is U1A right now, then it will be U1B, U1C, U1D, like that. Okay, so block by block, and each block or each banks are having their own decoupling capacitors and their power supply. So you can see this VCC of 3.3 volt is being supplied to this particular bank, which is bank 0, and this is going to be called as configuration block. So this is how you make sure that your design doesn't go wrong. Next is called as mode setting. So a configuration mode setting can be made in such a fashion that either it can be master serial mode or slave serial mode or master SPI mode or JTAG mode. Okay, so if it is in the form of 101, then it will be JTAG form. So how it happens is, this will be M2, M1, M0, and if it is 101, then it will be JTAG configuration mode. So this JTAG configuration mode can be by default set through this particular resistances. Okay, so I have put it like fixed configuration kind of thing. Otherwise what you can do is you can always have a possibility of changing it, right? So through this particular switch dip, I mean dip switches, you are going to keep it high or low based on your requirement. Okay. Now coming back to the done pin and init pin. So init pin LED indicator is there. So once there is a problem or something like that, init will go low, and this is how it will go off, something like that. Similar to that done pin, when there is a done pin configuration is completed, this LED will start glowing. Okay, so this will go high, and this is how it will go high. So why we have connected through like this is basically init pin and done pin is basically open drain pin. That's the reason you have to have a pull up resistors. Okay, that is the only reason. Then we have SPI flash memory. This SPI flash memory is going to be used for my configuration image saving. Okay, so this particular SPI flash is quad SPI, which is going to have DQ1, DQ2, and DQ0 and DQ3. And this is my CS pin, that is your chip select pin, and this is my uh, clock pin. Okay, all right, so moving to the next page, what we are going to have is, okay, here we have power supply voltage rails, LED indicators. So let us say we have several voltage levels in our FPGA system. We have 5 volt, then this is going to be like red color. We have 3.3 volt, which will also be red color. Then let us say you want to glow for 1 volt core voltage. So this is going to drive a transistor, and this is how it is going to turn on this particular LED whenever 1 volt will be available. Okay, similar to that 1.8 volt also this LED will glow, and 1.35 volt this particular LED will glow. So because 1 volt or 1.8 volt or 1.35 volt is not capable of having the forward bias voltage that much, that's the reason we are using 3V3 to drive those LEDs, but the enable will be through the power supply availability on this particular voltage levels. Let us move to the next one. Let us connect user IOs. Okay, so user IOs is nothing but let us say we are going to connect some push buttons. So you can see push button 0, push button 1, 2, 3, 4. Okay, so you can see whenever this particular user push button is connected to, let us say, one of the IO pin of this particular FPGA, here it is. Okay, so when it is connected directly, you can see it is high. So my FPGA IO will be seeing high. Now this push button is pressed. Okay. So once this is pressed, what will happen? This will get grounded, and this is how it will go low. So once it goes low, you will understand that the push button has been pressed, and based on that you can take an action. Similar functionality is there for all the other user push buttons. Okay. Next, coming back to the LEDs. So several user LEDs are connected through the MOSFET. So you can see you have LED 8, LED 9, LED 10. Okay. And similar to that, if you want to drive through FPGA as sync, okay, then you can connect user LEDs like this. So it will be driving through the like FPGA as sync. So whenever FPGA pin will go low, it will be glowing, and whenever it becomes high, this will be stopped and it is not glowing. Understood? Similar to that, if you want to act your FPGA to be a source, so this will be sourcing the current for these LEDs, and this is how it will be glowing. So whenever it goes high, this will start glowing. Okay, so like we have amber color, green color, red color, so many colors LEDs we have put it. And similar to that, if you want to have little bit higher current driving capability or something like that, so in that case what we can do is you can drive through the like MOSFET. So here my FPGA pin will enable this gate of the MOSFET, and this is how this MOSFET will turn on and LED will start glowing. So similar functionality is there for these two LEDs as well. Coming back to the deep switches, so deep switches you can see we have open pin left side. So this is connected directly to the FPGA pin, and whenever it is open, it means it will be grounded. So my FPGA will see a low, that is 0. Okay. Now, if you will push this particular dip switch to the right side, what will happen? This will get connected to my 3v3, and this is how it will become high. So my FPGA will see a high, that is 1. So this is how you can configure your FPGA pin for 1 or 0 at several methods. Understood? And all these pins have been mapped here, like we have user push button and user dip switches and LEDs. Okay, and in other banks also LEDs are there. Here you can see we have QSPI pins here. So QSPI pins has is connected here, like Mozi pin, Mizo pin, and all those things. But basically it is quad SPI, so we have connected like this. Then we have SPI. I am going to tell you here itself, like we have SPI, quad SPI here. Then we have ADC connected here, and then DAC is connected here, and then we have a MUX pin connected here. So all these things will be utilized in our next sections. Okay. Let us get into the next page. So little bit more LEDs were remaining. So we have connected into the other bank, which is bank 34, and bank 34 corresponding power supply, like decoupling capacitor is connected at this location. Okay. Then getting into the next one, we need to have a FPGA power supply decoupling capacitor. So you can see we have VCC INT pin, which is 10 number of pins are there, that is connected to my core voltage of 1 volt. Okay, and then we have auxiliary voltage. So auxiliary voltage pin connected to 1.8 volt. And similar to that, we have block RAM core voltage. So block RAM voltage is again 1 volt. So how it is connected is VCC INT with their corresponding decoupling capacitor is connected here. Then auxiliary voltage 1.8 volt with their decoupling capacitor is connected at this location, and block RAM voltage is connected to this location. So there might be a possibility that you will not see VCC auxiliary underscore 1V8. So that will be coming through one ferrite bead after the power supply voltage levels. Okay, that you can do. Similar to that, same 1 volt is appearing at this location. So what you can do is you can connect that particular VCC INT 1 volt, and then connect one ferrite bead, let us say 120 ohm, and then connect to your VCC BRAM 1 volt. So this is how you make changes, and this is how you bring this particular net name of the voltage level. Similar to that, VCC AUX was available. So VCC AUX with one ferrite bead and make a change underscore 1V8. Okay. And these are the ground pins that is connected. So several ground pins were there. So it is connected like this. Okay. Coming to the most important part, which is the power supply requirement for this particular FPGA with a proper voltage sequencing. So power supply voltage sequencing is needed, like which one will be high first and which one will be low first. So you can see we have 4 channels in this, like channel 1, 2, 3 and 4. And you can see the power supply sequencing is like this. We have channel 1 starting at 2 millisecond, then 6 millisecond, then 12 millisecond, then 18 milliseconds. So total 4 channels are there at a difference of 6 millisecond each. But first power supply will be starting at a delay of 2 milliseconds. So that is your soft start timing. Got it? And this sequencing mode can be configured through this particular voltage setting. So you can see here we are sequencing like this. Okay, or otherwise this one is also being used for some enable purpose, like which one will be enabled at what location. Yeah, sorry, this is going to be used for the voltage sequencing, and this is going to be used for the voltage level setting at the outputs. Okay, so this is the particular power supply that we have already discussed several times, and this is one of the most popular power supply, low cost power supply that I have seen, PMIC, which is going to give you quad output. Okay, and this is ADP 5014. So using this power single IC, we are going to generate 4 levels of output voltages. Okay. Coming back to the next part, which will be requiring a main power supply system. So let us say we have a main connector, and this connector is going to get connected to the power supply, let us say 12 volt, with fuse protection as well. And we have a slide switch here. So this slide switch will help you to enable and disable your like main power supply input to the board. So once you pull it up, okay, like pin number 1 and 2 location, then it will get connected, and this is how this gate will get activated. Okay, and this gate will be like pulling this particular gate of this P MOSFET to down, and this is how the power supply from this location will reach to this location. Okay, and here we have put one again like a Zener diode for voltage clamping or protection, you can say. And then we have a EMI filter connected at this location, and this is a voltage indicator, input voltage indicator, LED, and this is how you have a input voltage nicely coming at this location. Okay, so this is the input power supply with you have a fuse protection, then you have a voltage switching, and then after that again we have Zener protection, and then we have an EMI filter as well to reduce your any of the noise that is available in your incoming power supply. Okay. And then this particular power supply is going to convert your V input to 5 volt V output. Okay, so this 5 volt V output will be of 6 ampere rating. So this is particular like buck converter IC, which is going to give you an output of 5 volt 6 ampere capability. Okay, and this particular like current sense amplifier can help you to see like how much current is flowing through the output of this particular buck converter, which will be monitored through this 5VA sense. So this 5VA sense will be monitoring how much current is flowing through this particular output voltage. Similar to that, you have a like option of connecting this particular like 5 volt selection. So if you want, you can do that, like sort this two, then this particular output will be connected to my 5 volt input. Otherwise, if you have USB, you connect it like this. Okay, so USB connection I have not given in this particular schematic section, that you can like request it, and we will send you the USB section as well. Coming back to the next part, this is the most important part. We have several ADC pins that to be measured. Okay, so we have like VCC INT, AUX, VCCO, 1 volt, 1.8 volt, 2.5 volt, or 5 volt, 5 VSNs, temperature sense 1, temperature sense 2. So these many ADC pin I don't want to waste from the FPGA. So what I have done is I have used a multiplexer, and this multiplexer is going to give you based on the selection of mux pin A0, A1, A2, which is coming from the FPGA, right? So you can select which channel input you want to go to your output for ADC conversion. Okay, like if you select 000, then first channel will be selected. If you select 001, then second will be selected, like that. Now what we can do is, this particular input voltage is going to come at this particular place. After this buffer, it is going to get like filtered, like low pass filter, then again buffer, and then after that we have a 16-bit ADC with voltage reference of 3 volt that is being generated by this particular reference voltage IC. And then this is having an interface of SPI interface. Okay, so you can see you have chip select pin, we have clock pin, and we have data pin, and this data pin will get connected to my FPGA, which will be storing the ADC value of each of the input channels. Okay, so this is how you design your ADC circuit. Let us see the next one. As you can see, we have here DAC. Okay, so digital to analog converter. What we are going to do is we have like mapping of, let us say, chip select, clock line, and SDI, like the like input uh, pin. And this particular DAC is going to give you current output, and this current output is converted into voltage output, and this is how it is called as DAC out B. Okay, so DAC out B will be having a capability of minus 2.5 volt to 2.5 volt. Okay, so how it is being made is we have a voltage reference C which is 2.5 volt here, and then after this particular I to V converter, we have here amplifier as well as filter, and then we are going to get your output. This particular IC will be requiring a negative supply voltage as well. So this negative supply voltage has been generated by a negative voltage charge pump IC, and this IC is going to give you exactly whatever voltage you are going to give positive voltage, same positive voltage will be coming as negative voltage at this particular location NV5. So this NV5 is fed here. So this is a very good technique to generate a negative voltage supply. Okay, for powering up your op amps or DACs or something like that, uh, because they need very low amount of current, like 100 milliampere is more than enough. Okay, so this is having a capability of, I think, 100 milliampere or 16 milliampere. We need to see that. Next, I have put one SPI flash also. So this SPI flash is having a quad SPI capability like D0, D1, and then D2 and D3. And then we have clock line and chip select line. So this is having 512 megabits. So this is how you have a complete system design, and several sections can also be added into the several more sections can be added to the FPGA pins that is remaining. So this is a sample circuit that I am going to give you, like how to proceed with your different peripherals like push buttons, deep switches, LEDs, then SPI memories, like flash memories, or connecting some other peripherals like temperature sensors, USB interface, or even buzzers and all. You can run it. Okay, and even you can connect some EEPROM as well. So all those things you can do. So what I have done at last is, in the last page I have kept all these symbols that we have designed here. Okay, so what you are going to do is, this particular FTGB 196 pin symbol, you can see you have configuration block, then we have bank 14 and bank 34, and then we have power supply block, and we have ground blocks. Okay, so total five sections are there for this complete FPGA symbol. I don't want to make only single symbol with all the pins. That will be a cluttering. Okay, so basically you must have an understanding of which pins to be grouped in particular section. Okay, so in the IC data sheet or in the IC pin output itself, they have given like bank 14 is having these pins, bank 34 is having these pins. These are the ground pins, and we have VCC INT and auxiliary and block RAM power supply pins. We have configuration pins. So this is how they have been grouped. So if you do have any questions or any understanding that is required for your FPGA power supply design, or FPGA system designs, you can refer this particular trainings. Or if you still have any questions, you can put down your queries in the comment box, and we shall be able to answer you out. Thank you guys.